A simple needle, a tiny harmless object. But what if this needle were traveling at the speed of light? Could it pierce through the Earth? Could it destroy cities, or could it wipe out the entire planet? In this video, we'll explore the mind-bending physics, the catastrophic consequences, and the science fiction level possibilities of a scenario that seems impossible but is as fascinating as it is terrifying. Brace yourselves. This is a journey into the unimaginable. First, let's talk about light speed. Light travels at an incredible 299,792 kilometers per second. That's fast enough to circle the Earth 7.5 times in 1 second. For comparison, the fastest bullet only reaches around 1.7 kilometers per second. That means a needle traveling at the speed of light is moving at a speed over 176,000 times faster than the fastest human-made projectile. Mind blown yet? Keep watching. It gets crazier. Light speed isn't just a number. It's a fundamental constant of our universe. In fact, it's so integral to the laws of physics that Einstein's theory of relativity hinges on it. According to this theory, nothing with mass can reach light speed without requiring infinite energy. This is why spaceships, bullets, and needles cannot achieve this velocity under our current understanding of physics. Yet imagining the impossible gives us a unique lens to explore extreme scenarios and the raw, untamed power of energy and matter in motion. Now let's focus on the needle. At its core, it's just a small, thin object, lightweight, right? But here's where things get interesting. The faster an object moves, the more kinetic energy it carries. The formula for kinetic energy, 1/2 mv squared, reveals that energy increases with the square of the velocity. At light speed, even a tiny mass like a needle would carry an energy level beyond anything humanity has ever witnessed. For a needle weighing just 10 grams, the kinetic energy at light speed would be comparable to the energy released by an asteroid several kilometers in diameter. To visualize this, consider the Chicxulub impact, the asteroid that caused the extinction of the dinosaurs 66 million years ago. This needle, though unimaginably small, would rival that magnitude of destruction. When the needle reaches Earth, it first has to pass through the atmosphere. Normally, meteors burn up due to friction, creating the bright streaks we call shooting stars. But at light speed, the rules change entirely. The needle's velocity would compress the air molecules in front of it so intensely that they'd transform into plasma. This would result in a superheated fireball that could ignite the sky, creating a catastrophic explosion before the needle even touches the ground. The shock wave from this atmospheric entry would be unlike anything ever experienced. The air pressure alone could shatter windows and level structures thousands of kilometers away. And this is just the beginning. When the needle hits the surface, the energy released would dwarf that of any recorded meteorite or nuclear bomb. The impact would vaporize everything in its vicinity, carving out a crater potentially hundreds of kilometers wide. The seismic waves would ripple across the globe, causing earthquakes strong enough to split continents apart. Coastal regions would be inundated by tsunamis that could travel across oceans, obliterating entire cities. The intense heat would ignite massive wildfires, releasing clouds of smoke and ash into the atmosphere. This debris could block sunlight for years, plunging the planet into a nuclear winter scenario. Global temperatures would plummet, crops would fail, and ecosystems would collapse. The chain reaction could lead to a mass extinction event on a scale not seen since the end of the Cretaceous period. If the needle doesn't stop inside Earth and instead continues through, the destruction wouldn't end at the point of impact. Traveling at light speed, the needle would pierce through the mantle and core, leaving a trail of devastation in its wake. The immense pressure and heat generated could destabilize the Earth's tectonic plates, triggering volcanic eruptions and massive earthquakes worldwide. The planet's magnetic field, which originates in the core, could be disrupted, leaving Earth vulnerable to harmful cosmic radiation. Now, is this scenario even remotely possible? According to Einstein's theory of relativity, the answer is no. As an object approaches the speed of light, its mass effectively becomes infinite, and it would require infinite energy to accelerate further. This makes light speed travel for anything with mass a physical impossibility based on our current understanding. However, let's indulge in the hypothetical. Suppose advanced alien technology or future breakthroughs allowed for objects to move at light speed. This needle would become the ultimate weapon, a force of nature capable of reshaping planets. The destruction caused by a needle at light speed wouldn't be limited to Earth. Imagine if such an object were aimed at another celestial body. The energy released could destabilize moons, shatter asteroids, or even disrupt the orbits of planets. The ripple effects of such an event could cascade through the solar system, altering its delicate gravitational balance. While a needle traveling at light speed remains purely theoretical, this thought experiment serves as a humbling reminder of the power of physics. It showcases how even the smallest object, when pushed to unimaginable limits, can hold the potential for extraordinary destruction. It also highlights the fragile balance that sustains life on Earth. From the protective atmosphere to the stable tectonic plates beneath our feet, our planet is a marvel of natural engineering. But it's also a reminder of how much we still have to learn about the universe's untapped forces. So, the next time you hear about the speed of light, think about this. Even the tiniest object, traveling at unimaginable speeds, could leave an impact that changes everything. The universe is vast, mysterious, and filled with phenomena beyond our comprehension. Let's continue exploring, learning, and marveling at its wonders. If you found this fascinating, don't forget to like, comment, and subscribe for more thought-provoking content. Let us know what mind-bending topics you'd like us to cover next.